I'm just wondering how many people here do have disaster recovery plans or have a requirement for? Okay, a few. Okay. I'm going to suggest that the DR plans are probably quite individual, but they will have some common elements as well. So, hello, I'm Nic Clews. I'm a VMS ambassador. I didn't put my email address on there, but if anybody wants to contact me, I'm quite happy to do that. Okay, so the whole point, if you do have a disaster, is you don't want it to bring your business down. That's really the whole point here. Now, a lot of us are all probably sat in meetings, and there's that old joke about buzzword bingo where you listen out for those things. Oh yes, this is high availability tick. You know, you've got this little mental vision of all these business buzzwords that you keep talking about, but it really should not be. It should be treated really seriously. So, what I'm going to look at are some disaster scenarios, planning considerations about those, and also testing considerations on how do you actually make sure that whatever you plan is actually going to work, and also testing it. I can't emphasize testing enough here. And I'm also going to look at a real event as well, a real disaster. And at the end of, say, audience observations and experiences and questions and answers, I think I've got some questions for you. So, the important thing here is failing to plan is planning to fail, because how do you know in any one situation how you're going to deal with it? And things break, they always will. And we can't avoid the weather, and stuff will happen. And whatever it is, you could make a plan, but it won't suit the situation that you actually find yourself in. The only Monty Python reference I've got here is no one expects the Spanish Inquisition, but you've got to ask those questions. And if you've been present or heard any of my other presentations about stuff that shouldn't happen to system managers, this really is digging quite a bit deeper into those situations. They were funny at the time, but I didn't talk about how we recovered from them, and this is where we're going. So that session is available on the Bootcamp videos. If you go to Boston 2024, you can go and have a listen to that. You need to think outside of the box, and more importantly, outside of the server and the operating system. So although we're here about OpenVMS, and OpenVMS can keep going, but it might not be the actual source of the problem. And it is necessary for what we call critical national infrastructure services. I don't know if anybody knows in the UK, but we've had various retailers being taken down. Even yesterday, the tube network suffered a massive failure due to an electrical fault. So these things are still happening. The important thing, of course, is nothing is free, but what is the cost of downtime? And you need to measure that in terms of how much business you're potentially losing. So I expect most people are probably familiar with this, the HP disaster tolerant video where they blew something up, and VMS returned in 13.71 seconds. Does your business need to come back in that shorter time? There were some sysgen parameters that were actually modified in order to achieve that, particularly Reconex interval, and also the quorum was set so that the surviving node would still maintain quorum, and of course the shadow member timeout as well. That was all set up. So yes, VMS can do this really fast if you need it really fast. And so you had non-stop, UX, Windows, Linux, and then if you were right at the end, those three goldfish, Sparky, Blaze and Little Smoky, took them just under 5 minutes to recover. But do you really need 5 minutes to recover it? Okay, so in May 1993, in the digital documentation set, and if you go to a version 7.3 on CD, you will have a PDF version of this particular file. It is really interesting, and one of the things that it does do is really try to explain the difference between faults, problems, and other things that actually affect your dependable system. So it's an interesting book, but in a lot of ways it's quite simple, but it does have some interesting ideas. But it compares building cars and having accidents, these kind of things, and the difference between them. So you can see that it is available on the 7.3 documentation in the archive manuals area. So the current important business definitions that CEOs and people ask is this: the RTO and the RPO. So what's the difference between them? And this is quite often misunderstood. So basically, the question you have to ask yourself is, how long can the business survive without service, without whatever it is that your IT system is providing, before sustaining irrevocable damage? And that's really the point. And that's where you determine the cost of how much investment you put into saving your business and making sure it can come back safely. So the RTO is the recovery time objective. How long before normal or what is a workable service is resumed? How long have you got? When, or in other words, when is your business toast? When is the business just unviable because it's taken too long? The other item is the recovery point objective. And this is very much around data integrity. What data safe point do we need to restart that service? So it's all well and good having all these relational databases and all these interconnected databases, but you need to have a clean point where you know that the whole set of data, regardless of it being just on the VMS system, across all your systems, has some integrity. So you know all the transactions are lining up and you haven't missed anything out. Because that's the point when you run a database check and find that there's a record missing somewhere. You don't want to be there. So it's that important clean restarting point. And the other thing is, when things do go down and they do stop, is there a manual fallback? Can we gather things on bits of paper? Can we cache bits of data and save them so that when the systems do come back online, we can actually feed them back into the situation, so at least some elements of the business can continue? And is it 24 hours or just business hours? There can be some definitions, although right now, most people expect always on. And you might have sort of regular processing during the day and then overnight batch runs that must complete before the next day starts. So you've got to think about all these things. And what is your worst case scenario? What is the worst thing that could possibly happen? So, input-output examples. I'm thinking about one particular system that I'm working with here. We have these radio frequency scanners. So as things are going out, they scan them and it sends a little message onto the VMS box, prints out a dispatch note, and we know that that item has gone out. But nowadays, it may not be limited to that. Lots of people are using mobile applications, ticket sales, for example, boarding passes for aircraft. If they're on your mobile system, and you can't get them, you can't get on the aircraft. And data from other systems. So there might be transactions, there might be a load of information that you're processing. Your VMS system or your system might just be one key component in the whole lot. Dispatch documents I've mentioned, and results to web apps. Everyone expects to press a button and get a result. Reports and data feed in other systems, transaction confirmations as well, and process control. And this is really where things get interesting. Is it controlling the steel plant? Is it running the electricity grid and doing the balancing for everything? Does it need to be fault tolerant, mission critical, just high availability? All these are considerations. So what could possibly go wrong? Well, when it's Murphy's Law, anything, quite literally. Networks fail. I quite often call them not works. Link failures, configuration errors. I mean, somebody could be updating a bit of firmware somewhere and all of a sudden it stops something from communicating. Physical damage, vehicle collision. So a true story here is we had a production system and a development system that we use for disaster recovery. It had important network links to another site in the south of the country. And then a van rolled off the road and hit a communication cabinet and took out both links because they were both going through the same cabinet. Here's an interesting one. I only learned relatively recently, Carrington event of 1859. So we didn't have computers then. We were all communicating using Morse code. But I don't know if you know at the moment, but the sun is highly active at the moment, and we've seen a lot of aurora in places we wouldn't expect to see them. But in that particular year, there was such a violent storm. It was induced on all the electrical telegraph cables in the US, and lots of stations actually set on fire. That was a real event, and that is still a potential threat for the UK. Well, for the globe actually. So we're at solar maximum now, starting to go down, but it could happen in another 11 years. Who knows? Service provider failures. A lot of us are quite happy to say, oh, networks, we'll let somebody else do that, or we'll let somebody. They could have issues that you are not in control of. So you need to eliminate any single points of failure. Power failures, air conditioning failures, they fail. But you could have a power failure, your air conditioning goes down, but your servers keep running, and then the server room temperature just cooks up to the point when the server says, I'm over temperature, I'm shutting down. We've had numerous UPS, so everybody has uninterruptible power supplies. You should always test them, always change your batteries. But it's quite easy to hit the wrong button and kill the power to the entire data center. Now, this happened on more than one occasion. And it's all right having generators as well, but what happens if your generator runs out of fuel? And bad weather and other fault-induced issues with power. Software failures as well. So regardless of the inability to correctly test things, insufficiently tested code could corrupt your data. So you could put something in production, it'll run for a while, and then later on you discover it has corrupted a whole load of data. There are malicious threats around. So at the moment, VMS is pretty immune, but the issue could be the data that is coming in could be maliciously affected. Or you could get fraudulent access, or even insider threats. It's something we're taught to be aware of, is that maybe someone's going to get terminated in a few days. You need to remove their access, because if they wanted to do some damage and they've got the ability to do, they could cause significant problems. Cyber attacks, and the issue is, of course, AI is a big enabler for cyber attacks now. Systems do crash, of course. Clusters hang, and perhaps you've made some changes and you've tried to reboot the system. For whatever reason, it hasn't rebooted. What changed? We don't know. And flooding, weather in general, human error. We can all make mistakes as well. I mean, once upon a time, I was working on a development in a test system. I forgot which one I was on, and I deleted a production database. Not the best place to be. So in setting up and designing your plans, there are really two key groups of people. You've got your systems analysts. They're the people that know how the system is put together, and then having a business continuity planning team. So most businesses probably have them. How connected are they to you? I don't know. But between you, you should be able to form this sort of stuff. System design documents, they're really important. And also the operating system, the application, and the hardware configurations. These are all things that you should know. You should have these to hand. If you have not, this is a great time to write them and try to understand how the systems actually work. The business process as well, understanding where the systems fit inside the business as a whole. And all the support documents as well. How do you do this? How do you do that? They all form part of it. And training documents as well. When you get new people, how do they know? Does somebody just sit at the side of them and tell them to do this? Or do you actually have this process documented? So out of all of that, you actually have additional disaster recovery processes and documents. So what happens if? How do you recover from it? So as I say, if you don't have the documentation, get it written. So here's a few what ifs. So you've got to mind map scenarios. What on earth could possibly go wrong? What is your worst case scenario? So if you we have geographically separated data centers with clusters between them. Could they really both fail at the same time? Is that a possibility? What about if the wrong data center continues to operate and you've corrupted all your data or corrupted significant data? So you've got to trace the inputs and the outputs, any network dependencies, application dependencies, single points of failure. Always look for those. Know where your backups are, and importantly, how to restore from them and how long it takes to restore. So how many people just make a backup and then send the tape off without actually reading it back? Part of our backup process actually reads the first save step back on the disk just to prove we can read it. All right, we're not reading to the end of the tape, but we have some confidence that what is on there is readable. And also you need to determine how much compute is needed. So if you do have multiple systems in a cluster, how overloaded are they? If you could you run with just half the systems or a third of the systems? So you need to do some capacity planning around all of this. And who are the stakeholders? Who are the people who can actually say to you, yes, we have a working service? You need to make sure you've got the communication to them so you can notify them there's a problem and then check with them that the service you have running is actually sufficient. And how would you get from a partial or a failed service back to a full service? So if you do lose a data center or you do lose some systems, how do you actually bring them back in without being disruptive to the current operation? So it is more than surviving the disaster. You've actually got to get your resiliency back too. So there's other situations where disaster recovery plans can be useful, and we've done this quite a few times, and we've got one coming up later this year. Lift and shift moves. We're actually going to be moving part of the cluster from one location a few miles down the road to another location. So we will actually invoke the DR plan in order to enact that. Also major operating system upgrades. So it's all well and good. A lot of people are quite nervous about doing their operating system upgrades because, oh, what if something doesn't work? Well, if you have that plan on standby and make your changes and then prove to yourself that it's working quite happily, you can use your DR plan to fall back or actually continue your service on the working systems. So I know there's a lot of talk about having shared system disks and things, but I'm a big believer in actually having separate system disks. And the only thing the system disk has on it is all the files ready for booting. And anything else, all of the shared stuff, is kept away from those operating system disks. And similarly, having separate dump and paging disks as well. Always keep them away from your application. And it's a good performance reason too. Application upgrades as well. So your development team have come along with something, right, we're going to deploy this. So you could actually just separate one of your systems out, separate out one of your working systems, just keep it isolated so that the old application is still available to you, and then just run with the upgrade, and you can very quickly switch back if there's a problem. And reversing decommissioning, funnily enough, this does happen. We'll say, oh, we don't need this system anymore, we'll switch it off. So we go through what we call a green mail process, leave it off for a while, then all of a sudden someone shouts, so, oh, we need this system. So it enables us to bring the systems back online. And also replacing servers, doing upgrades as well. That's another point where this can be really handy. And hardware upgrades in general. So you need to test your plan, and it needs to be as realistic as possible. And lots of people are tempted to actually use the test systems, but this is not replicating your live environment. So if you're too nervous to use your live systems, could be a sign that, you know what, your plan might not even work. Your business is too nervous to do this. You know, you don't even think it'll work. So why did you even waste time designing that plan? If you're not prepared to do it on your life systems, your plan is potentially useless. And so I would say to you, you've no plan. So you've got to test it. So the best way to do this is to actually run it as a project. So you need a project manager overseeing the actual test plan. You need to have all the right people in place and the timing of it as well. So when we're doing these tests, we make sure we're avoiding month end or any other critical points in time as well. Also, people are not on holiday, for example. And what you should do is start to estimate how long is it going to take us to do this, how long to do that, how long to do the other. Note them down. And then you've got to make sure you've got people that will validate that it's working. So when you have got your disaster running and you're running on half your systems or whatever it is, you've got to have people that say, yes, I'm happy with that. That's work, that's sufficient. Also, some contingency. What happens if things go wrong? So as you start to go through your plan and then something unexpected happens, you need to recognise whether you need to back out and deliver a full service or whether you can continue. And of course, make a note of whatever has gone wrong. System baseline performance. Gather your baseline performance now so you know what you expect to see. And you need to know what normal is. So we saw earlier this week about the digital test manager. So maybe you should run a few tests there and then run them afterwards and compare your results, and you will give yourself some confidence that it's working. And review your results as well and change the planning. Are your timings correct? Do they need to be altered? So, execution, follow your plan, estimate your times, make your network changes. So the way that we do this for a particular cluster is we've got DNS resolution, which goes out to any of the 4 nodes. So if someone comes in, they want to log in, they'll get thrown out to a node. So the first thing we do is switch that off. We limit it to the nodes that are going to remain up. This is all for cluster load balancing, of course. We disable logins on the server. We move the application workload because we actually have multiple batch jobs. We close them all off on the systems we're going to shut down and move them over to the servers that are going to remain up. We then shut down the systems, remove nodes. That's an important thing because it causes a cluster reconfiguration so that the voting is altered for you and you do not lose quorum. Observe and validate the situation. Make sure that what you're seeing looks correct. And then get confidence in the stakeholders that the performance is acceptable and there's no adverse access issues. So the users need to have their own set of tests to prove to themselves that the limited working service is providing a good working service without affecting the business. Then after that, of course, reboot and recover your systems. So here's a big thing for us. So data replication. So half the data is on one side, half the data is now stale. So we now start to bring up the systems. So that starts all the shadow copies, which all start to recur. And then the workload is moved. So it was working on 2 nodes. We now move it to all 4 nodes. We make the DNS changes so that users can now access all 4 systems rather than just the 2. And again, log the time for each activity. So you've actually got an expectation of how long it takes for each one. Now, here's a really important one, and this is something we're going to do. We were asked by the business, have you tried powering the systems off? We've done DR tests before. Have we ever switched the stuff off? No. So this is one of the things we're going to do. Because it's part of a DR test, we are in a controlled environment. If we've got a working setup, if we switch them off and then try to switch them back on and they won't come on, at least we know we've got a working service. But some systems that have been on for years and you try to switch them back on will not come back on. Been there, seen it, and worn a t-shirt of that. So, but this is an important test as well for power failure. Because what happens if in the middle of the week you have a power failure and then the power comes back and you can't switch your server back on. So it's a great opportunity to test that. So let's look at a real world cluster. Okay, so the recovery time objective is less than 4 hours. So if that system stops, we need to get service back within 4 hours. That's our target. Otherwise, we have financial penalties. Recovery point objective. How much data can we afford to lose? No more than 30 minutes. So the processes either side have enough to keep going for about 30 minutes, and that's gathering the data. We do have a lot of fault tolerance. We're using virtual LAN for the inter-site connectivity. We've got IP clustering as well as the normal clustering as well, running concurrently. So is it a fault tolerant service? I'm going to say it isn't, because this isn't non-stop, if you're familiar with how non-stop works. But it is mission critical, because this is serving the whole UK for medical services. And if it went wrong, we would be in the news, and the whole service would be in the news. So it is important. Is it high availability? Yes, it is. So we've got LAN failover. We're using 3PAR. We have RAID 6. So RAID 6 gives you a little bit more protection. We've got 4 member shadow sets, 2 at each site. And the way that backups are run is that we actually peel one set off at one site for the backup process. We just kind of freeze the application briefly. And we've got dual inter-site links and dual path networks. Everything's dual everywhere we can be. So here's a plan. So Friday lunchtime, we do a few checks, make sure everything looks good. Nothing failed. Management notified. They let the users know we're all going ahead. DNS service change. We stopped the logins, moved the batch jobs. Later in the Friday afternoon, we shut down systems with the removed node. The shadow sets are now reduced from 4 to 2 members because we have MSCP serving between sites. And then Sunday morning, we reboot the removed systems, we remount all the shadow sets, do some health checks, reset the DNS, distribute all. So it all sounds like quite a simple plan. That's a very high level look at it. Didn't work, did it? Okay. So what we discovered was that 2 nodes were totally insufficient processing power for the weekend and overnight processing. Jobs completed late, we abandoned some. We only just managed to complete the backups within the window. We looked at the performance data, and we went back to management and said, you know what, these systems are not powerful enough. And the T4, in fact, the baseline data we gathered, it did suggest to us we were going to struggle. So we had the information ahead of time, because we were already 70–80% busy when we had 4 nodes. So it was obvious that we weren't going to have the power. So we went back to management and told them what the problem was. So we bought some new systems. Hooray! So we replaced the integrities. We got i6s. We also upgraded at this point to VSI VMS. So this was obviously a few years ago when we did this. We went from EVAs to 3PAR, went from LTO 4 to LTO 8. Although because we have a historical reading requirement, we kept an LTO 6 drive in there so we could read the old data. All the intersite net links, so we all went from 1 gig to 10 gig. We also took the opportunity to revisit the disk layout, add some more drives as well. But we did retain the VLAs and VLB, so we've got dual LAN failover. We have complete new racks. And then when we looked at T4 data, all the servers were peaked about less than 40%. And we then created a new disaster recovery plan. So, second test plan. Similar activities. So we did all the same sort of thing, but we're starting to take the systems down, and then people are going, what's going on? What's happened? What's happened? That was the culprit. Shadow member timeout. 4 minutes, as you can see, 240 seconds. So what we failed to do as the systems went down, it shut down the MSCP links, and of course the systems that were sat there were looking at the shadow sets that have just gone away, so they didn't time them out. But other than that, it actually went quite happily to plan. The overnight batches completed, backups worked, and then we did the shadow copy next day. So everything was great. We did the third test. Now, here's the important thing. We swapped sites. We don't have a primary site or a secondary site. We make sure that both sites are capable. Because you might say, oh, we'll just use this site all the time for the DR tests. What happens if that's the site that goes? So you've got to test both scenarios. So we can do backups, obviously, at the other site. So we moved that prior to running the tests. So we did the same. Distributed batch jobs relocated, DNS repointed, logins disabled. So what we did do was we dismounted the shadow sets, the actual individual members on the systems that are being closed down first. That was from our lessons learned from the second test, and then we shut down the systems. Now, of course, the bit I was missing from the other one is forcing quorum at the console, because of course we've got equal voting system. So we have deliberately designed the system to hang. So if we do lose one site, it hangs. It waits for a human decision. So that human decision is to decide what has failed at what site. Is it the network? Is it the systems? Exactly at what point? So that you know where your safe data is. That's really critical. But it all went really smooth. Everything was good. And then, of course, we had all the shadowing on the Sunday. So the important thing was, are the backup devices at the secondary site functional? So moving them the day before was a great idea. But in fact, we actually invoke weekly backups at the other site just to make sure that the tape drive is happy and working. Because we did actually discover another point that we tried to use it and the library mechanism just failed. So it wasn't the drive, it was the library. So it is important to make sure that everything, just exercise it, just get it to move at least once a week. So then, of course, the project manager running it all, they made sure that all the issues and everything was captured and everything was working. So it validated the plan. And it's the whole VMS team. So it's no use having just one person doing the same thing every time. You need to get the whole team involved. So everybody's got experience of doing these sort of things. So everybody gets the experience. So restoring, boot the systems into the cluster, remount the shadow sets. So we're using DTCS, Disaster Tolerant Cluster Services. I know there's one user. Anybody else use it? So DTCS does have some really clever functions when it comes to shadow disks. So you could end up with a situation due to timings, due to whatever, that you've got a shadow master on one site, a shadow master on another site. So this will manage that whole process and make sure only the current shadow members actually serve as the sources for the copies. So this is just a little bit more about DTCS. So it's a former digital offering, but Force Platform is a company that are currently running with the service, and it does a lot of routine monitoring. So one of the things that it does is twice a day, it says, hello, I'm here, everything's working. If we're missing disks, if we're missing processes, it will send out alerts. So it's doing, and it will also do dynamic system changes. So sometimes you might to redistribute the way that free list works or modified list just for the application load. If you've done a lot of investigation here, you can actually use it to dynamically change sysgen parameters. And it checks all the shadow sets, make sure everything's there. And the important thing is when you're doing a full boot, so you might think stuff, well, maybe I should do a minimum boot before a full boot. Well, with DTCS, you can do a full boot because it can then interject with the menu to allow you, give you much more control over some critical parts of the booting. More importantly, mounting shadow sets, because that is quite a tricky area. So it does protect the shadowing. So And the important thing is it is designed to be multifunctional. So it doesn't care where the disaster started. It more cares about data integrity. So we actually had a real failure. And guess who was on call at the time? Yeah. So this was 10:30 at night. And I get an SMS and the app was notifying me, we've lost a node. Oh dear. We've lost another node. Oh dear. We've lost another node. This is really bad. What's going on? So this really happened. So this occurred when we were splitting shadow sets. So we're starting to peel off the shadow sets. And one by one, we lost one node at one site. Then we lost another node at the other side. And then we lost a third node. So we only had one node with one set of disks at one side. And of course, it was completely hung, just sat there. So we got on there. Now, we had the DR procedure, and in there it says make your network checks. So the management stations that we used, that validated the fact that it wasn't not a network problem and that the network was fully functional. So we're quite happy with that. We ruled out the network being a problem. So we then thought, how are we going to bring this back? Excuse me. So first of all, we brought back site 1, node 2. Of course, we still don't have quorum at this point, but it did join the cluster and it sort of sat there. It saw the disk, it saw everything, but it just sat there. We then brought back one of the other nodes from the remote site. And then of course, we start to have quorum, and then we brought up the final node. Now, we did all this within half an hour, within 30 minutes. So we were well inside our recovery time. So quorum regained, the shadow merges started because we are using mini merge here, and the copies commenced. So we had some in mini merge and some doing full copies. And of course, we used the DTS CZX menu as it came up, said, how do you want to mount the disks? So we went for a full mount and it did all the validation for us. Because we were starting late with this, we decided to abandon the overnight processing and the backups. We just kind of forgot all of that. And then later on in the week, that one node that had stayed up actually crashed. And that crashed mid-morning, but it had exactly the same footprint. Needless to say, we passed the crash dumps off to VSI, who looked at them and said, you're a bit out of date with your patching. And it was exactly the same footprint. So as a result of this, we actually did some patching and upgrades. But importantly, we did not lose any data. We have no client penalties. So, in summary, we're close to the end now, where you get the questions. Okay, so plan and documents. That's really the important thing. And try to think as many scenarios as you can, but try to think of the impossible things as well. Expect the unexpected. I really can't emphasize that enough. You know, trucks running into network cameras. We didn't know that our network provider, although we'd asked them for 2 links, were using the same cabinet for both links. And validate your production plans. You've got to use your production equipment. It sounds really scary. You've got to convince people to do it. Otherwise, you don't know if it's going to work or not. Experience is everything. So actually trying it and doing it, it means that when it is sort of 10:30 at night or something, because that's when it does occur, how on earth do you actually cope with that? So in an uncertain world, don't be the nail in the horse's shoe. We all know that proverb. So we're at the Q&A. So before you ask the questions, I'm going to ask you some questions. Should you set your systems to auto boot? Okay.
What we do.
Yeah, you got to think about it. That's the important thing. So, do you use, so let's say you're using SMS on your phones or whatever, and a lot of us now have that ability to set the do not disturb. 11 o'clock, I'm going to get some spam call, or, you know, some friend's going to be sending some joke. I'm not interested. Phone, do not disturb, and it automatically goes on. How do you allow those alerts to come through? If they come through at 3 o'clock in the morning, your phone needs to make a noise. Does anybody know? I've got an answer here.
Well, I would expect that you have a multi-person team and somebody, not necessarily you, is always available. That, and it's on shifts.
Well, yeah, there is yes, there is a kind of an escalation process, but really you don't want to be the person that's asleep while it's happening. So yeah, so you put the calling numbers into your favorites, and then in the settings allow favorites to message you, so that if they're on your favorites, they will come through even when your phone is in do not disturb. Okay, so that's how you do that one. So yeah, that's the thing, setting your priority numbers. How do you force quorum on your platform? So if you have lost quorum, what do you do? What's the commands? How do you do it? Yeah, and?
D/I, well.
Okay, you're talking back. Yeah, okay.
Yeah, I get into the IPC prompt
Yes.
and then Control Z. Getting into the IPC prompt is different from wax alpha.
Correct.
And I
Correct.
And I could use, for example, AMDS if I have
Correct.
that running or availability manager. Doesn't that disaster tolerant DTCS?
DTCS has the same function. Yes, you can actually use that. Yeah. And I did ask a question. It's the same on x86, Control P. You can get into IPC. You press Q and it will restore your quorum. And you can also reset any mount verification on there, of course. So that's your tool. But of course, the thing is, yeah, availability manager. Yeah, that's the AMDS availability manager. Yeah, that's correct. And here's another one. When are quorum disks useless?
Multi-site cluster, I would say.
We're getting there. When you've only got one system being a quorum disk watcher, it's pointless. Okay, any other questions you want to throw at me?
I was wondering, like, the recovery time, is that a business decision or is it coming from the engineering?
It should always be a business decision. It is the business that need to determine exactly how long they can survive without systems and when they need to come back. As we saw in the DR video, yeah, you could make it 13 seconds, but is that realistic? So but the real key thing about all of this is the data integrity. It's all well and good doing things really quickly, but you've got to do things properly and maintain the data integrity. That's really the key.
Have you considered doing 3-site cluster so that, or will it be killer cost wise or killer performance wise?
It's expensive to do. So you have to determine how much is it going to cost to have 3 sites, because of course with volume shadowing you can have up to 6-member shadow sets. So in this case, yeah, so you've got 2 members at one site, 2 members, add a 3rd site, you can have another 2 members. Yes, you could do that. And that would give you much higher sort of resiliency. But remember that you can't have them as just as a triangle, because every system needs to be able to communicate with every other system independently in a cluster. That's how clustering works. So if you lose your network link between 2 of the sites, that will cause a problem, because if you've got 3 sites you've got A, B and C. If A loses connectivity with C, then that is going to cause you a problem. So you could be introducing more issues.
Yeah, but this is definitely obviously a land-based cluster because there's no way nowadays to do
Yeah.
anything else. Do you use independent, absolutely separate lands to kind of do your cluster traffic?
That, yes, we do. So there are multiple network providers that we use. So one of ours is provided by one provider and the other one is provided by a different provider. We, to our best ability, ensure that they're not going to use the same because particularly in the UK, a lot of providers simply go back to the old British Telecom as it was years ago. They still provide the backbone services. So it's no use just falling back to that. Fortunately, there are other providers that have provided their own independent networks now.
Diversely routed.
Yeah, diversely routed, yeah, correct.
And your network people are not fooling you. I mean, sometimes it appears that there's a LAN infrastructure here and there's another LAN infrastructure here. And it's kind of separate and totally, except that it isn't because the trunks are still.
Yes.
And so the network people can just rebooting the freaking switches, ruin your life completely.
Yeah, absolutely. Yeah, so when the systems are set up and the networks are designed and all the top of rack information comes in and how the whole systems are powered as well, because I mentioned this in one of my previous presentations about the fact that dual powered doesn't mean coming from the same power distribution unit. They do have to be different, and it's the same for networks as well. And again, the network equipment needs to be independently powered as well. So yeah, keeping duality all the way through is so important. Anything else? I'm happy to take any other questions outside, but thank you very much.